In this short video, I will demonstrate how to solve a sequential move game without a game tree. In particular, a game tree will not be provided, and I will not take time to draw one. Instead, I will solve the sequential move game using the payoff matrix alone. Let's consider the game depicted below. We have two players. Player C chooses the column, and player R chooses the row. Player C has two choices, C1 and C2, and player R has two choices, R1 and R2. Our goal here is to solve for the equilibrium if the game is played sequentially, with player C moving first. So this is a sequential move game where C is the leader, which makes R the follower. I want you to remember that sequential move games are solved by backwards induction. What does this mean? This means we need to start by defining our follower's behavior, so R, essentially deciding what R will do in response to each potential strategy chosen by the leader, the first mover. Once we know what our follower will do, we move backwards and decide what the leader should do, taking into account how that follower will respond. So essentially what we need to do is we need to ask ourselves a few questions. If player C, the first mover, chooses C1, what should player R do? So we're asking ourselves how our follower will respond. So we're using backwards induction, we just haven't built a tree to do it. So let's take a look. It says player C is choosing C1. So we're here in this column, and we want to know what player R is going to do. Well, if they choose R1, they'll get 50. And if they choose R2, they'll get 1,000. I think it should be fairly clear what's going to happen here. If player C chooses C1, player R's response will be R2, because that's the payoff maximizing response. Then we have to ask ourselves another important question. If instead player C chooses C2, what will player R's response be? Similar exercise. Player R says, okay, player 2 chose C2. If I choose R1, I'll get 800. If I choose R2, I'll get 100. Clearly, 800 is greater than 100. So player R's payoff maximizing response is R1. So if you want, you can almost think of this as a highlighting exercise where we say if C1 is chosen, R2 is chosen in response, and if C2 is chosen, R1 is chosen in response. So that's us dealing with the end of the game. Now we move backwards from the game, from the end there, and we ask ourselves the following. Player C says, okay, I know that if I choose C1, that R is going to choose R2. And if I choose C2, R is going to choose R1. So player C compares the to pay attention to what's going on here. Player C has two options. They can either get, let me choose the right pen here, 800 if they choose C1, or they can get 1,000 if they choose C2. So I sort of conceptualize what's going to happen, how the follower is going to respond, and build that into player C's responses. Clearly, 1,000 is better than 800. So player C's choice will be C2. So notice that I worked backwards, identifying what the follower should do in each possible scenario. Then I had my leader, C, incorporate that into their decision making. They didn't concern themselves with these payoffs or these payoffs because those are out of equilibrium. Those are not paths that the follower would choose. So they compared the two outcomes, choosing C2 and getting a response of R1 to choosing C1 and getting a response of R2, and they decided that C2 was better. So we have our full equilibrium. Player C chooses C2. Player R responds by choosing R1.